Okay, so continuing 7.1, let's consider why was it that sine of 105 was the same as sine of 75? So let's see x and y coordinate axes. Let's say we have a unit circle of radius 1, 2, 3, 4, 5. Oh, why is it doing that? 5, 5, 5. Oh, almost something like so. Okay, let me erase this bottom part. Okay, so let's say I have an angle of about 75, maybe about here. So this is 75 degrees. Let's say I have an angle of 105 degrees. It's about here. So 75 and 105 is 180. So these are both the same reference angles, which means that the value for sine, the y-coordinate, is exactly the same. So sine of 75 degrees is going to be exactly the same as sine of 105 degrees, okay? Because they're at the same reference angle with respect to the x-axis, namely 75. So what's interesting about that is, let's say we have, I wonder if there's a way I can copy this. Copy, paste. Oh yeah, it keeps it at the same angle approximately. And now let's do the same thing here. Let's copy, paste, and let's make sure there we are. Okay, now let's say I have a triangle. Where should I put this? Like so. Well, there's two possibilities. I could have the triangle. So let's call this A, B1 onto C1. Or I could have the triangle A, B2, and I guess C is just C. So let's make C purple. No, I've already used purple, orange. Okay, so we have the 75 degree angle for the purple guy. But then we have the 105 degree angle here for the green guy, right? But notice that the radius, we were on the unit circle, so do you agree that the length from A to B1, that length, or the measure, which doesn't have the macron over it, so that measure is the same length as from A to B2? Because we know from our unit circle they were both the same length. So that is equals to the radius. So this length here is the same as this length here. It's the radius. Okay, so this is what's known as the ambiguous case. There's two possible triangles that will have sine being the same. So sine of angle 75 has the same value as sine of 105. So there's a problem here, and this is known as the ambiguous case. So note, in the ambiguous case of sine, the ambiguous, is that how you spell it? Ambiguous case of sine. There are two triangles. two triangles. Which satisfy the given condition. Which satisfy by the given condition. Okay, so let's see this in action with a couple examples. So for example, let's consider triangle ABC. So consider triangle ABC such that the measure of angle A is 60 degrees. Let's see. The length of side A is 3, and the length of side C is 3 times the square root of 2. So show that there are two possible triangles which satisfy these conditions. So show that there are two possible triangles, meaning this is an ambiguous case, two possible triangles with these conditions. Okay, so let's go ahead and draw a triangle. Any random triangle, because of course there's going to be two of them. So I guess this should be C, should be A, this will be B. So I'm given that measure of angle A was, what did I want to do? Did I want to change that to 30 degrees? Yeah, let's change this to 30 degrees. It'll maybe make my life easier. 30 degrees, not 60. And let's have the length of little side A be 3. And then the length of little side C be 3 times the square root of 2. Okay, so notice this is the case. What am I given here? I'm given side angle. Do you agree it's first side A, side C, then angle A? So this is side angle. And which were the two cases where the law of sines doesn't work? Side, angle, side, and side. So the law of sines will work here. So this is a side, angle. Okay, so let's say we want to find angle C first. So now I'm going to use the law of sines the way it initially appears. Sine of angle C over little side C is equal to, what color should I use for A? Let's use green for A. So let's do sine of angle A over little side A. Okay. So we have sine of angle C. Angle C is what we're looking for. Divided by, well, the length of little side C is 3 root 2. Why is this not working? 3 root 2. Okay, clearly there are issues with this. I don't know why. So 3 times the square root of 2. And that's equal to sine of 30 degrees divided by 3. Okay, so of course I want to cross multiply by 3 square root of 2. So I get that sine of angle C is going to be equal to sine of 30 degrees times 3 square root of 2 divided by 3. Okay, so the 3's reduce at this step. So I get that sine of angle C is going to be sine of 30 degrees is 1/2. And then I just have root 2 left. Okay, so look at that. This says that sine of angle C is the square root of 2 over 2. Okay, so that means that angle C is 45 degrees, or 135 degrees, right? Could be in quadrant 2. So 135 or 45. Okay, so there's two possibilities as of now, right? Okay. So let's do case 1. So number 1, if C is 45 degrees, this implies that angle B, what color should I use for angle B? Let's use blue. So blue for angle B and little b. So that means that angle B will be 180 degrees minus 45 minus the measure of angle A was 30. Okay, so in that case, B would be equal to 105, right? Okay. Okay, so in that case, if B is 105, I can solve for little b, so little b divided by sine of angle B, I'll set equal to, once again, little a divided by sine of angle A. Okay, so this is little b divided by sine of 105 degrees. Okay, that should be familiar since we did two problems similar to that before. Side A, little a is 3 divided by sine of angle A is 30 degrees. So now let's cross multiply by sine of 105 degrees. So I get that little b is going to be equal to 3 times sine of 105 degrees, all divided by sine of 30 degrees. Okay, so little b is equal to 3 times sine of 105. Well, that was the square root of 6 plus the square root of 2, or vice versa, all divided by 4. And sine of 30 degrees is 1/2. Okay, so what we get is that 2 goes into 4 twice. So we get that little b is going to be equal to 3 over 2 times the quantity, square root of 6, plus the square root of 2. Okay, so in that case, I will have solved that triangle, right? However, there's case 2. Case 2 is if angle C is, well, I did the 45, so now let's do the 135, or the 45 degree reference angle in quadrant 2. So let's see, B was in blue. So capital B in this case will be 180 degrees minus 135 degrees minus 30 degrees. So I'm actually subtracting 165 from 180, so that leaves me with 15 degrees. Okay, so before moving on, let's note 15 degrees can be written as 45 degrees minus 30 degrees. So if I have sine, what color should I use? No, let's use green. So if I have sine of 15 degrees, I can write that as sine of 45 degrees minus 30 degrees, which will be sine of the first, sine of 45, times cosine of the second, 30, minus, because it's sine, so the SIGNs correspond, sine of the second, 30, times cosine of the first, 45. So we have Sine of 45, of course, is the square root of 2 over 2. Cosine of 35 is the longer guy, so it's a square root of 3 over 2. Minus sine of 30 is the shorter guy, 1/2. And cosine of 45 is the square root of 2 over 2. So once again, this looks very familiar, doesn't it? Only there's a subtraction. Now we have the square root of 6 minus the square root of 2 all over 4, which you should recall from earlier in the semester. I made you guys derive this. Okay, so now if that's the case, what is little side b? So now in that case, we have little side b over sine of angle b. And we're setting that equal to little side a over sine of angle. Oh shoot, did I do that right? Yeah, sine of angle a. Why did I? Oh shoot, I used the wrong color, didn't I? Oh well, okay. So this will be little side b divided by, in this case, sine of 15 degrees. Because that's what b is in this second case. And I'm setting that equal to little side a, which was 3. So little side a is 3 divided by sine of 30 degrees. Okay, so cross multiplying by sine of 15 degrees, we get that little side b will be equal to 3 times sine of 15 degrees, all divided by sine of 30 degrees. So we get that little side b is equal to 3 sine of 15 degrees we found to be the square root of 6 minus the square root of 2 all over 4, and sine of 30 degrees, of course, is 1/2. So I can reduce in the denominator. 2 goes into 4 twice. So I end up now with little side b being equal to 3/2 times the difference, the square root of 6 minus the square root of 2. Okay, so there we are.